Hi class, this is course 3, lesson 13, adding and subtracting fractions and mixed numbers. Okay, if you remember all of these facts here, these steps, you'll be successful with adding and subtracting fractions and mixed numbers. First, you must have common denominators, so make it happen if you don't. If you need help with that, let me know, please. Second, add or subtract the fraction part, then add or subtract the whole numbers. Third, when subtracting, that's subtracting, so make sure you know that means subtracting, mixed numbers, you may need to rename the mixed number, which is borrowing, and we'll do an example like that. So if you have same denominators, I'm going to do a couple examples on each of these. So same denominators, here's an example. You have 4/5 and you're going to add to it 3/5. Denominators are the same, so we leave the denominator alone, add 4 plus 3, and we get 7/5. Now we cannot leave 7/5 as our answer because 7/5 is improper. We have more groups, so we can make a whole number. So we're going to divide by the denominator. 5 goes into 7 one time with a remainder of 2, and then that remainder becomes our numerator and our denominator is our divisor, and that's our answer. Let's do a subtraction problem with the same denominator with a mixed number. 6 3/4 minus 1 1/4. Okay, now notice I have a horizontal arrangement and a vertical arrangement. I find when I work with mixed numbers that it's easier for me to keep everything straight when I use vertical. When it's just fractions, it seems to make more sense working horizontal. But do what makes sense for you. Okay, so back to example number 2. We have same denominators, so we leave the denominator alone. And then we can just subtract the numerators. So 3 minus 1 is 2. Then subtract the whole number part. 6 minus 1 is 5. But then check to make sure that your fraction is in simplest form. 2/4, we can reduce that by 2 2's because 2 and 4 have a factor of 2 in common. Now when you do this, do not forget that you have that whole number piece, so put the 5 there, then 1/2. Okay, do not just put 1/2 here and then expect me to put it together. You can write 5 1/2. Let's do a couple examples with different denominators. Here's example 1. We have 4 1/4 plus 3 2/3. Okay, we're going to add those two together. Now notice 4 and 3 are not the same numbers, so we need to get a common denominator. And in this case, we would multiply by 3/3 in the top number, and the bottom number here would be times 4/4. That'll give us a denominator of 12. Okay, so then what I like to do is this, and then I write my whole number back down, and remember that it's an addition problem, and then I do the fraction. 1 times 3 is 3, 4 times 3 is 12, 2 times 4 is 8, 3 times 4 is 12. Now I'm going to add, so I keep the denominator. 8 plus 3 is 11. Add the whole number part. 7 and 11/12. And 11/12 has no factors in common other than 1, so I know that's my answer. Okay, let's do a subtraction problem. We'll do 6 1/2 minus 2 1/8. Okay. Now I know that I can use 8 as my least common denominator, so I only have to multiply this top fraction by 4/4. Okay, so that will get me 6 and 4/8 And then this one's just going to write down over here 2 1/8. And I'm going to remember to put my subtraction sign there so I remember what operation I'm doing. Again, the denominator stays the same. 4 minus 1 is 3. 6 minus 2 is 4. So my answer there would be 4 3/8. Okay, let's do an example where we subtract with borrowing or renaming. Okay, so we're going to do 6 1/9. Oh, let me start that over. Same number, but I want to write this bigger. We're going to go 6 1/9 minus 2 2/3. Okay. Again, first, do you have common denominators? No. You need to change 2/3 to be in terms of ninths. So I would need to multiply this fraction times 3/3. Okay, so I would have 6 1/9, and this would become 2 6/9, and I would try to subtract. Now, I have a 1 in the numerator and a 6 in the denominator, and I can't do that. So I need to borrow. And what happens is when we borrow, we do borrow 1, so this becomes 5, but the one that we borrow a whole unit, and it has to be 9/9. So we're going to add 9/9 because 9/9 is 1, but we need it to have a denominator of 9. So when we borrow 9/9 as 1, our new problem up here is 5 10/9. Okay, so I add the 9 and the 1, and I leave the 9 alone. And then I'm going to just move this one over, and it's minus 2 6/9. Okay, so leave the denominators alone. 9, 10 minus 6 is 4, 5 minus 2 is 3. So my answer is 3 4/9. Okay. So this is the tricky part right here. Remembering that you're borrowing 1, but it's written as the fractional component. Okay. One other thing that we need to do is to model. I'm going to give you an example of how to model this addition or subtraction on a number line. Okay, so if we wanted to do 2/3 plus 2/3, we would write a number line that would have a 0 here, and then maybe this is a 1 and this is a 2. But then we need thirds, so in between the 1 and the 0 we need to make 3 equal groups. So there's 1, 2, 3. And we have to do that again here. 1, 2, 3. So then 2/3 would be from 0. We would go over 2 of those groups. That's 2/3. And then we'd need to add another 2/3. So we would go over to another 2/3. And we would end up with, at the spot, 1 1/3. Subtraction works the same way. We just go over to the right and then go backwards for subtraction. If you want an example of subtraction, please let me know and I will be glad to demonstrate that in class. Oh, look, I did that on the wrong page, so we don't have to worry about this at all. Word problem example. Make sure you write this in your notes. Tony has a length of rope that is 27 2/3 inches long. He cuts a 2 3/4 inch piece from the rope. How long is the resulting rope? Okay, so now this is one of those times where you think, is this a combining problem? Is this a separating problem? Equal groups? All those different types of plots that we have to pick from. And hopefully you can identify that this is separating. We had some, we're going to get rid of some or cut some off, and then we want to know how much is left. So our problem is actually 27 2/3 minus 2 3/4. Okay, can we do this yet? No, we need common denominators. So I'm going to multiply between a 3 and 4. My common denominator would be 12. So multiply by 4/4 and multiply by 3/3, giving me 27 8/12 minus 2 9/12. Oh, look at this one. This is the bonus problem. I have 8 and I need to take away 9, so I can't do that. So I need to borrow from the 27, making that 26, and I'm going to add to this 12/12, which gives me 26 20/12 minus 2 9/12, and now I can subtract 20 minus 9, 11, keep the denominator of 12, 26 minus 2, 24, which would be inches. 24 11/12 inches is the resulting rope. So that was, hopefully it's review for you, but the borrowing when we subtract always seems to be a little tricky. So please let me know if you have questions. Otherwise, I'll see you in class.